Hello everyone, welcome to our channel. In this lecture, we're going to solve a problem related to energy and momentum principle. The given problem is calculate the critical path for a discharge of 6 meter cube per second in the following section of channel. The sections are circular section having diameter of 1.5 meter, rectangular section having bed width of 3 meters, trapezoidal section having the bed width of 2.5 meter and side slope 2:1, triangular section having the bed slope of 1:1. So let's start solving this. First, let's carry out the given data. In the given data only discharge is given. Discharge Q equals 6 meter cube per second. So in first we'll start solving circular channel. The area of the circular channel can be given as A equals D square is divided by 8 times of phi minus sine phi equals 1.5 whole square is divided when the diameter is given as 1.5 times of phi minus sine phi equals 0.28 phi minus sine phi, and the t equals d sine phi is divided by 2 equals 1.5 sine phi by 2. Now at the critical depth, can be given as t q is divided by t equals q square is divided by g. On substituting the value, the a means 28 times of phi minus sine phi cube is divided by this one sine phi by 2 equals q is given as 6 square is divided by 9.81. So on solving this, the value of phi will be 4.664. Now the critical depth can be given as yc equals d by 2 times of 1 plus cos phi by 2, where the value of d is 1.5 is divided to 1 plus cos 4.664 is divided by 2. So on solving this, result 0.23 meter, which is the critical depth on circular section having the diameter 1.5 meter at discharge Q. Now let's go for the rectangular channel whose bed width is given as 3 meter. In this, the critical depth yc can be given as q square is divided by g times of 1 by 3 equals, this can be transformed into q square as the discharge is given times of b divided by b square g whole power 1 by 3. So placing the value is 6 square, this b is 3, and the value of g is 9.81 power 1.3 equals 0.74 meter, which is the required critical depth for rectangular section while given the discharge 6 meter at width 3 meters. Now in fourth, we'll go to trapezoidal section. In the trapezoidal section, the bed width given as 2.5 meter and side slope z:1 is given as 2:1. So at critical depth, a cube is divided by t equals q square by g. This can be written by yc plus ycz whole square is divided by b plus 2ycz sorry, this one is up to this much. the T is given as B plus 2YZ, where A equals BYC plus YCZ square and T equals B plus 2CZ, or placing the value of on this, the value of B is 2.5, YC plus YC, and the Z is given as 2 is divided by 2.5 plus twice of YC dot 2 equals Q means 6 and G means 9.81. So on solving this, the value of while C is equals to 0.69 meter, which is the required critical depth for the trapezoidal section at discharge 6 meter cube on the width 2.5 at the side slope 2:1. Now in the fourth, we'll go to the triangular section at side slope z:1 equals 1:1. At critical depth, a cube by t equals q square by z. Area of triangle can be given as zyc whole square power 3 is given by twice of zyc equals q square by z, where yc can be written as twice of q whole square by g z square power 1 by 5. So placing the value on this, 2 times of 6 whole square is divided by times of 1 whole square power 1 by 5, and solving this, the result will be 1.49 meter, which is the required critical depth for the triangular section at the discharge 6 meter on side slope of 1:1. So for this time we end up the solution, and this video after this much will come again with one new video. Till then, keep on watching our channel and don't forget to subscribe us. Thank you.